Welcome. Let's discuss the case where a secant and a tangent line intersect in a circle. In the past, we have shown a conclusion when two secant lines intersect. If we get the length of one secant line, which we can call it r, and we multiply by its own external segment, which we have called it s, that is going to be equal to the length of the other secant line, which we have called it t, times its own external segment, which we have called it u. But remembering that this is true when two secant lines intersect, well, what if we have one tangent line and one secant line? Do we still get the same result? Well, let's start by drawing one secant line. Let's call the intersections A and B. And now, let's draw a tangent line that intersects at the end of the secant line. Let's call the intersection C. And the point that the secant and the tangent line intersects, let's call it P. Let's assign the same name as we did with the line segment AP. Let's call the external line segment S, and let's call the whole secant line R. Now what we want to think about is, how are these two scenarios related to each other? Now let's think about what would happen when we get the length of the whole secant and we multiply by its external line segment. Well, previously, we have said that is equivalent to the length of the other secant line times its external line segment. In our new scenario, notice that the length of the tangent line is also its external line segment. So if we assign a name to the length of the tangent line, let's call it f, then the result of t times u, which is the whole line segment times the external line, is going to be f times f. The length of the whole line segment, t, is f, and the length of the external line, u, is f as well. So now we can simplify it as r times s equals f squared. So if we want to put this in words, we can say that the length of the secant times its external is equal to the tangent square. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.